Hey everyone. So kind of got a lot to go through here. I'm gonna try and explain stuff from the beginning, but also do some advanced stuff and go through real world applications of Node and Docker. So, okay. So first of all, what is Docker? There's a lot of talk about it. You know, maybe there's some hype. It's a lot of people are talking about it, wondering what the hell it is. Well, Docker is very simply lightweight container virtualization. So what does that actually mean? If you're familiar with Linux or relatively low-level Unix systems programming, you can think of Docker as a wrapper for Linux, LXC, and C groups plugged into a copy-on-write file system such as AUFS, for example. So it's a wrapper for other existing low-level kernel components. What's a container? So a container, I've sort of written a little equation here to try and get it across what a container means in Docker speak. You could think of a container as a running instance of an app. So this could be, for example, a Node Express app that you've written, plus its dependencies. For example, that might be Redis, or MongoDB, or MySQL, or whatever else you need, including Node modules, Node itself, anything else. Plus network. So network just means typically means the exposure of a single port, but could be more complicated, plus a command that is actually running the container. So here's an example. My container equals my app plus Node version 10.25, plus Node modules, plus Ubuntu LTS, which is your system image, plus the network is exposing port 3000, plus a command to start your app, which might be something like node index.js. So that's sort of what a container is. It's a running instance of these things in the world of Docker. So that's really all Docker is. That's all it is. But Docker happens to be greater than the sum of its parts, as many good, interesting technologies. So I would say, here are three things that I really think about when I'm considering what Docker is. It's sort of a container IDE. I'm using the term IDE very loosely speaking here, but an integrated development environment. So if you want to create a container, according to my previous definition, Docker is a great way to create that in an interactive way. So you have tooling to do that. It's also a sort of a interchange format or specification for these containers. So it defines things like how networking can work, within what parameters, what sort of options can be passed to commands, how limits such as memory limits and so on can be applied. And finally, the thing that you're dealing with most often when people talk about Docker, the command line utilities, Dockerd, the daemon, the network daemon, it's a sort of a container runtime and lifecycle manager. So it enables you to start, stop, create, run, modify, inspect, ship, etc. containers around. So what Docker is not? Docker is often talked about in the context of some of these other things. And it's important to be clear that Docker itself is quite a constrained piece of technology. It's kind of a fundamental low-level tool that wraps other existing stuff, but it doesn't do too much itself. So it's not a load balancer. It isn't an orchestration layer. It's not a configuration management system. So it's orthogonal to something like Puppet and Chef. It's not necessarily about the same type of things. It's not a service discovery solution. So it's not etcd or it's not Zookeeper. And it on its own is not a private PaaS. It's not, Heroku running on your own server. So it's none of those things. So here are some use cases. I think some interesting use cases, some more commonly talked about than others. So one that I personally like is the software distribution use case. So this would be what we described earlier as a container being an application plus its dependencies. So typically today, if you look at GitHub, if you look at a project on GitHub, an open source, web application, that's going to be just the app. It doesn't also include the dependencies such as, most web applications require some persistence layer, maybe that's MySQL or whatever. They require a language runtime like maybe PHP or a specific compiler or whatever. So they're not bundled up together. They're not composed in the same way at the same time. You have to go out and maybe, if you're installing WordPress, you need to go and get PHP and Apache configured and MySQL and all this other stuff installed. So Docker gives you a way to actually distribute all of that together. So in fact, there is a sort of an emerging community of people developing Docker images of popular open source applications. I'm pretty sure there are, for example, some pretty good WordPress Docker images, which mean that you don't have to go out and install PHP. You don't have to go and configure Apache. You don't have to go and configure MySQL. And so that ties into another point later, which is kind of your deployment pipeline, in the sort of DevOps sense. If you're deploying code in a software organization to production or whatever, that's really the connection there, that it's a method of distributing this stuff together. Some of the other things that it gives you, which are nice, it gives you something like a virtual machine. There's no hypervisor. There isn't a virtual machine. It's all the OS kernel. So if you're not familiar with LXC or cgroup specifically, it's a feature of the Linux kernel, which is basically like chroot. If anyone is familiar with the Unix system called chroot, you can think of LXC and cgroups as chroot on steroids. So chroot gives very roughly, it binds an application into a particular subtree of the file system, so that your application, once it's running and bound inside of that chroot jail, as it's sometimes called, it can't back up and look at the rest of the file system. So it's a way of isolating it. And LXC and cgroups expands that to cover other areas. For example, it can't look up at perhaps see other processes that are running or send signals to other processes that are running outside of its container. There's all sorts of things that you can do that might be more associated with virtualization, such as how much memory can be allocated, how much I/O performance can be allocated, how much network bandwidth, and so on. So there are a lot of things in common, but the thing to remember is that it's at the OS kernel level. It's not happening at the hypervisor or virtual machine level. So one of the advantages of this is that it's very fast. So one of the slow things, if you're familiar with EC2 or something like that, booting an instance can take a long time. Depending on the instance size, how big your AMI type is, all this sort of stuff. It could take, 15 minutes. That's not unheard of for an EC2 instance. Because this is not a new machine, it's not a virtual machine, it's already running inside of a running kernel, there isn't a boot up process. So there aren't any network interfaces to initialize. There's no hardware to configure or anything like that. You get instantaneous VM-like sort of sandboxes, which brings us to the next point, which is security or isolation. So it's a way to run perhaps untrusted code. Maybe you have code that, maybe a good example of this is someone like Heroku, a platform as a service such as Heroku, where you send your application to Heroku, they execute it for you in the cloud. Well, they have to be able to securely run, or at least have certain guarantees about what your code can do in order to run it in their environment. If they run your code and you can just get root access and then start sending spam all over the internet, well, that's not good for them. So they use something similar to Docker, the same underlying technology, which is cgroups and LXC in the Linux kernel, for that. And so that's something that Docker can provide. This sandboxing, security, isolation, you can think of it like that. It's also this sort of deployment pipeline output. So this is what I was talking about, where maybe in a software organization, each product team perhaps, instead of having to output, their app along with install instructions and all this other sort of stuff, all of the dependencies get baked into a container. DevOps or Ops or the sysadmins or whatever you'd like to call that group take that binary image. They don't have to really look inside of it. They don't have to know how to particularly configure it. The interface is simply that you take this application, you run it on a Docker server somewhere, and a port is exposed. That's pretty much what it gives you. And this can be very useful in the typical software release process inside of an organization, which, you know, you could kind of call maybe continuous deployment is sort of like the, you know, the holy grail or whatever, what many organizations are looking ultimately to do with their software process. So you could see Docker as being a great way to consume or utilize the output of a continuous deployment process, to actually deploy that. You could think of it as Docker. And finally, I think that it's a great tool to use when you think of a service-oriented architecture. Because of these kinds of interfaces that I've described, that, for example, a Docker container, you know, exposes a set of ports or has certain memory limits, or you start it in a certain way, it's a nice interface that if you use that will kind of force you to break things out of being one monolithic, huge application into many smaller services, which maybe are deployed as individual Docker containers. So I think that's a popular approach that lots of organizations are using. So, just to go back to the specific details, or some of the specific details of how you might think about Docker containers. A Docker container is just a Unix process. That's all it is. If you run PS on the host, you can simply see the process that's running inside. So it's just like any other Unix process with some special, you know, security and isolation features. But it's not magic. There's nothing entirely different about it. It's reusing all the stuff that any, you know, multitasking operating system has fundamentally. So here's kind of a sample topology of how you might use Docker. So this is pretty simple. This is a standard web application topology, really, where you have a HTTP reverse proxy sitting in front of some physical hardware and load balancing or routing requests to various services. So in this case, it happens that, you know, there's a simple diagram. I have two physical Docker hosts, let's say. Each one is running multiple containers. They're each running on separate TCP ports. And then the HTTP reverse proxy is configured with the routing. Whether that's, in my own case, the way that we operate at my company, everything we do is routed based on vhost. So we use DNS and vhosts very heavily for our services because we make web applications. And so we pretty much map Docker containers to HTTP 1.1 vhosts. So that's something you can do. But of course, you can come up with your own topology. I guess the point is that it's not fixed. So you can use this any way you want. So this is our method. I'm just going into a little more detail. So specifically, by default, if you run a Docker container, let's say your Docker container exposes port 3000, like your average, I think that's the default express port, is to listen on port 3000. That inside the container service is listening on port 3000, but on the host machine, to avoid conflicts, Docker will map that to a random host, a random port on that host. And so it's kind of up to you to map whatever external service to that particular port. So like in that example I gave just previously, we're using a HTTP reverse proxy to do that based on vhost. You could use something else. And we use this method, which I'm not going to go too far into, but we built this tool called Dockerfile, which is a way for encoding these mappings into the actual image name. So what I'm going to do is I'm just going to jump away from the slides because it's kind of our introduction of Docker and it's a little bit abstract. So network willing, let's see. Okay, so apparently I have network. Okay, so this is what the Docker command line tool is like. Just to give you some specifics, I'm running this inside an Ubuntu something or other box. So it doesn't run on OS X, just that's the main thing. So this is some kind of virtual machine. So I have some images here. So you can see here that these are these things called repositories and tags. And I've got these Ubuntu things here. And that kind of corresponds to the base Ubuntu installs that you'd expect at these different versions. And then I have this thing called Nilo/Strider, which happens to be a Node application that I've developed and that's distributed in Docker container form. But just to give you a quick example, I'm just going to run a command inside of, Ubuntu. Let's see what happens here. So we'll do Docker run. I'm going to specify it as an interactive command. So this is as if, standard input and output are being piped through to inside the container. Okay, which let's try Ubuntu and just see what happens. I'm just going to run the shell. Okay. So you can see that there's only a single process from inside the container running. It's just, there's a shell. Well, there's two, I guess, that also was running PS. But there's only one process for all intents and purposes. If I do, you'll see that it has some memory, has some disk space. Let's see. It's not available. Let's see. It's the kernel. So, okay, all I'm going to do here is I'm going to go into /temp. I'm going to touch a file. Okay. So, now what's happened is, if I do a docker ps, see there's nothing running. But if I do docker ps-a head, we'll see that there was one running, which has, see that ID that I've highlighted? Has the same ID here, tells you the image name, tells you the exit status, it tells you the command that was run. And what I can do now actually is, I can commit that. So I'm just going to call that docker commit. Well, I'll just show this, docker commit. Docker commit container, which is this ID it gave me here, and I'm going to call this Docker demo. Docker demo. So now I type Docker images. Now I have a repository called Docker demo. Now if I do docker run -t-i docker demo, let's see, does this work? So you can see that that file exists. Whereas if I run it under the Ubuntu image, no such file or directory. So I've from I ran a container from an image. You can think of a container as like an instance of an image, plus any modifications that happen at runtime, such as, you know, the modification I made there was to touch the file /temp/foo. And then what I did was I created a new image from that container which had exited, and I called it Docker demo. And now for any future runs I can just base it from there. So this enables you to build things, sort of, literally the word is actually layer. It uses a feature of a UFS, this copy on write file system called layers. And so the only difference between Ubuntu and Docker demo is actually that temp foo. That's a 0-byte file. So it's not like a full duplicate of the entire Ubuntu base system. It's just that single difference, which is, you know, a tiny change. So what you can do with this to show, I'm going to jump to something quite a bit more complicated now from here, is, so this is what's called a Dockerfile. Hopefully that's legible. So this is what's called a Dockerfile, and this is how we build an image that represents our blog. So our blog is at blog.frozenridge.co, and what we do is we apt-get install nginx, add a bunch of static files, static HTML files, which are generated by Jekyll, if you're familiar with that static file blog software, add an nginx config, and then we say that the start command is, you know, nginx to run it in the foreground, and we expose port 3000. And that's how we build our blog. So this is exactly the same. This Docker file is executed by a command called docker build. And all it does is it does the equivalent of running all of these commands inside of the container for you. So docker run is the same as doing, you know, docker run Ubuntu, whatever the command is, apt-get, upgrade, or whatever. And then it will persist the container to an image for you. And you can start from whatever you want. So this starts from Ubuntu 12.10. You could start with whatever other image you wanted. So these things are additive. It's like you can build a graph from these containers and images. So this is a very simple example, and there are a couple of special commands in Docker files, which are all documented. So there's this add command, which adds files from the host file system into your image. And then command sets the default command that's executed. If you type docker run name of image, it will execute this shell command here. And then expose just means what port should be exposed to the host. This is for security reasons. You have to be explicit, because if you have an application maybe that exposes all sorts of secure or rather insecure ports without really realizing it, so that other applications on the host system can't access it. So you have to be very explicit with which ports are exposed. So let's go to a more complicated. This is an open source project, which is something like Jenkins, but it's written in Node. And so this is a much more complicated Dockerfile, as you can probably see. Let me try and make this a bit bigger here. Okay. So here we're actually at build time creating users. You can think of this as just if you yourself had a real world Node application that's using Express and that, requires an underprivileged user. And this also happens to include MongoDB. It has an SSHD, so you can SSH into it while it's running, stuff like that. Like a real world thing. This will install Node. You can see all of the steps here. So it installs MongoDB via apt-get. It makes a bunch of directories. It sets the locale. We use Nave to install the latest stable version of Node. We create a root password so that we can SSH in, but only from the host. Clone the application source code from GitHub. Run an npm install. Start up a Mongo daemon. So this in the real world, you probably don't want a database running inside of the container. You likely want it somewhere else, but this is just sort of an example so you can run it with no issues. Run some other commands and inject some config. And this thing exposes port 22 for OpenSSH and 3000 for the web application server. So I have this Docker image built here. I'll just kind of show you a little bit more. Docker images. Okay, so I have this thing here, and you can get this. This is an open source application. You can type docker pull nilo/strider, and you'll get this too on your system. So I should be able to do docker run. Let's see, port 3000. Let's just see what happens. So I'm telling it that port 3000 I care about. So this is all running inside of the container now. You can see that all these processes have started running. And maybe some of them have stopped running. So let's see. It started running again. Okay. So now in this other browser, in another window, okay, you can see that it's running. And port 49155 is mapped to port 3000, which is our Express server. I don't actually want that. I'm just going to tell it to explicitly do what port? 49125. 49125 colon. So this is how you make an explicit mapping in Docker. Okay. Starting up again. Let's see what's going on. Okay, so now you can see it's using the explicit port. It's running. Okay, let's see what happens. This is my Chrome running here. Let's see. Okay, well, it's running. So that's cool. Let's try logging in. Okay, so I'm logged in here. What I'm going to try doing is, this is if people are familiar with OAuth, this application uses OAuth very heavily. And so if you're familiar with developing for OAuth, it's pretty difficult to configure for development. So what's going to happen now, I'm going to try OAuthing with GitHub for this application, which is unconfigured, and it's going to fail. And the reason it fails is because there's nothing running at localhost. So I need to pass some config through to my application. But my application is running inside a Docker image. How do you do that? Well, one way that I've been using pretty heavily is simply to use environment variables. So I just save this command here, but I think hopefully that's legible. So I need to give it a server name, which is UVM port 49125. I give it a GitHub OAuth app ID and a GitHub OAuth secret. These are things that are required for OAuth to work properly. Probably most people here are familiar with that. So let me just take this. I use the -e option to pass that through, and Strider is aware of environment variables, so it'll utilize those. So I'm going to kill this thing first. Okay. Okay. Oops. So docker run -p. just copy this. Excuse me. I have to go back, and I don't have my shell configured. Sorry. There we go. Much faster going that way. Okay. So let's see what happens. Okay. Both running. Now logged out because this is a completely new instance. Okay. Come on. There we go. It worked. Just bounced me straight back. So that's how you do config. So now, just to sort of show you, I can go and run, you know, as many instances of this thing as I want. I mean, I can go and, well, I'll kill this one. So what you can actually do is, here I'm not supplying the -d option, which just means run in daemon mode or detached. So I'll do that again. But I can run like, cannot start container because that port is already in use. So can run a few more. You can see how if I give it the random port, it's going to be really slow. No, it doesn't work in here because of the way the keys are mapped. Sorry. Okay. Okay. So it's just kind of random. You see how fast it's running these things? Got a whole load of them running. So it's really fast, and you can do that with your web application once you have it running. So I thought from here, I think I have a couple more slides. Let me just talk through a couple of things, and then I'll just go kind of to questions, because I'm sure people probably have lots of things they're interested in. Okay, so here's just a couple of things I'd like to mention that are cool. If you're interested in Docker, here are a few things to look at. So I guess the thing I'd like to mention first is to check this thing out called Dokku, D-O-K-K-U, which is, if you've never used Docker before, you're not really super familiar with like, you know, DevOpsy things like setting up, you know, load balancers and vhost routing and all this sort of stuff, is a really good place to start because it does all of this for you. And in fact, if you're using something like DigitalOcean, I think you can just boot a DigitalOcean droplet and click a box and it will already install Dokku onto it. So you can check that out. And that will let you use your own server and deploy to it using Docker containers as if it were Heroku. So you can just git push your source code to, you know, another remote and it will deploy to this thing. And under the hood, it's using Docker. So that's a good way to get started if you want to start playing around with this. Another thing that's cool is Docker trusted builds, which I haven't talked about yet, but there's a public registry of Docker images on the internet supported by Docker Inc. And you can push whatever you want there, but what you can also do is you can OAuth with your GitHub account and register any repo you have on GitHub that's pretty sure it has to be open source, it has to be public. That has a Dockerfile in the root of it, and it will, on every commit, build that Dockerfile for you in their cloud, push that image into the registry, which is actually really nice because if you're building one of these things on your laptop, I mean, it could take half an hour easily if you're doing a lot of complicated apt-gets, you know, pushing that over the network, it could easily be 5 to 500 megabytes, no problem. So they'll do all that for you. So check out Docker trusted builds if you're doing this with open source. Another thing that's cool is if you want to control Docker itself from Node, there's a really good library that I use called Dockerroad, which is worth checking out. And then if you're interested in this kind of more complicated web app example, check out Strider CD, which is the application I was looking at and showing you guys. And you can Docker pull nilo/Strider if you want to look. But yeah, that's it. And I'll go to questions now, and I'm sure people will have stuff. So thank you.
If you're using a service manager like Upstart, would you typically configure that for your process in the container, or would you somehow like watch the containers process and and reboot a new container?
So the question is about, I guess, process lifecycle within containers that are running. At this time, Docker itself doesn't have an awareness of that. And so it's up to you to ensure that, for example, your web application is auto restarted if it crashes or something like that. In the example I was showing you, I know I went over it really quickly. I was actually using supervisor-d, and it would manage the underlying Mongo, Node, and SSH processes. So you can use supervisor-d if you want. Other people might use Upstart. I'm not entirely sure how that works. I'm sure you could use it if you wanted, but I think the key idea is it's up to you to manage that yourself. From within the container, right, yeah. Any other questions? Yes, sir.
So on this mapping here, those random or in some cases specified ports are mapping to port 3000. How do you connect to port 22 on that image?
So here in my command, I haven't actually mapped port 22. Because it all has to be mapped explicitly for security reasons, you can't at this time access port 22. So that's just telling you there's something on port 22 in this container, but you can't connect to it right now because you haven't mapped it. So you have to do that explicitly.
Can you retroactively add a port, like say like, oh, I want to log into the second one?
That's a good question. The question is, can you retroactively update, I guess, this port mapping? I'm not sure right now off the top of my head whether Docker itself will do that for you. Under the hood, it's just IP tables. So there's nothing stopping you from just doing that with IP tables. But right now, I'm not 100% sure. There might be. Any other questions? Yeah.
Is there a way to have a private repo for Docker images?
So the question is there a way to have a private repo for Docker images? Yes, there is. And so the software that runs what's called the registry, so Docker Inc. have their public registry, which I was talking about, is open source. So you can run an instance of that registry, and plenty of people do. I think that most of the storage is backed by S3, Amazon S3, so you don't even need the disk space yourself. It persists to S3. And there's also various little software as a service companies sprouting up that will host that for you. One that I can think of that I played with a little bit is called Key, QUAY.io. So K or key.io. And I think they might even give you private, registries for a small number for free. But yes, you absolutely can do that. I think we'll see more of that. Like that's very important infrastructure if you're using Docker. So, okay, yep.
I'm worried about the sandboxing of processes within Docker. If I understand correctly, you can run multiple processes within a Docker instance, right?
That's correct.
And can those processes spawn child processes within the Docker process as well, or is that, and that's all sandboxed within the single Docker process?
So I think the question, I guess, is about the security or the hierarchy of the processes once they're running within Docker containers. Right. Yes. So yes, that's how the security works. It's similar to how that works in chroot. So if a chroot daemon forks child processes, they're also subject to the chroot limitations. So it's like it inherits from the parent process, the security policy, basically. So, there are probably, if you really wanted to enforce that for some reason, I'm sure there are settings. There's a lot of tweaks you can make using Linux C groups. If you want to go into the details of that. But I think it's basically safe to say that yes, they inherit they live within the same container as the parent. They don't live outside of the parent. Yeah. So it's recursive. I hope that answers the question. Any other questions? Sarah over there.
Earlier you mentioned not wanting to run MongoDB inside the container. I'm assuming that's for performance reasons. First of all, is that the case? And second of all, is there a correct way of running databases inside a container, potentially by persisting to a different disk?
That's a really good question. So the question is, what are the implications of running a database within a Docker container, performance or otherwise, and what are the solutions? So the main issue or reason you wouldn't want to do it in a naive way is due to the copy on write file system. So although the copy on write file system is stable and it's pretty fast, you probably don't want to be writing, hundreds of gigabytes of data, if you're doing megabytes of writes per second to it. That's just going to be very expensive because it's a copy on write file system. So the second reason maybe is simply because you don't want your data living within one of these containers. Like you don't want it kind of logically inside a container, maybe because it's difficult to back up or it's difficult to copy or, access later. Because, if you think about containers and the way they're used, even my examples here, they have kind of a short life cycle. Data generally has a very long life cycle, so you want it very separate and durable. So there's that kind of idea there. But I think the main reason is performance. So the solution is a feature called volumes, which is where Docker will, I believe the term is bind mount an external Linux volume, which is not AUFS. So it does not have the overhead of the copy on write file system into your container. You could do this manually. You're able to do that for a while, but now there's a nice mechanism built into Docker for doing that. It's called volumes. That's the name of the feature. And you can use that, that would be the recommended way to deploy a database. So you could certainly use that. So you can do that. There's no performance penalty. The data actually lives on the host. So I'd recommend checking that out. Yes, sir, over there.
Yeah, we watched you kill some of the Docker instances, and does that propagate the right kill signal down to the processes underneath?
So the question is, I ran Docker kill. Does that properly sort of kill things in maybe a way you might expect in a Unix system? So does it propagate that signal down? In my experience, yes, it's fairly reliable, but I will say that, Docker is a maturing technology. And so I'm pretty sure I've encountered bugs with kill signals and things like that. And I have certainly been able to wedge machines running Docker in the past. So you might have to kind of kill it with fire by rebooting the machine or something like that. Like that can happen. But, that's a bug, right? So like in theory, yes, it should do that properly. And if it doesn't, it's a bug. Hopefully that answers the question. It should work. If it doesn't, kill it with fire.
I'll do 2 more questions.
Okay. In the back, sir.
So I'm kind of comparing this to a VM, and I'm still trying to wrap my head around this. So you can, for example, run a VM with different operating system or different Linux flavors and things like that. Can you do that on Docker, or does it use the base like Linux?
So this is a question about how the Docker kind of virtualization runs, or whether you can run different OSs in the same way you can inside a virtual machine system. I think the simple answer is no, because it's a single kernel that's running on your machine. It's not really, it isn't a virtual machine. I think that it's not really a good way to think about it. It's really a bunch of processes which are kind of made to look like virtual machines, but it isn't. It's the same operating system. So you can't run a different kernel. You can't run Windows inside Docker. You can't run, OS 10 inside Docker or anything like that. What you can do, however, is assuming the userland components of another Linux distro. Like say, for example, my host here inside this virtual machine is Ubuntu. I believe, I've never tried this, but I believe I could pull, say, a CentOS Docker image, which is basically the CentOS userland. So all of the non-kernel bits that comprise a CentOS machine, and assuming they're compatible with my kernel, which I presume they are, execute them. So it would sort of pretend to be CentOS or pretend to be a different distro. So I think the answer is that right now, really the best you could maybe do is sort of fake another distro of Linux, but you couldn't actually run a totally separate kernel. So I think hopefully that answers the question. One last question? Okay, yes, sir.
You had several images that have a root image in common. Are these changes actually saved? Are they just the changes saved, and how's that done? Or are they actually whole images that are copied?
So that's a very good question. The question is, how are the differences between images stored in terms of how are they actually persisted to disk? And this comes back to the particular file system that you're using. So initially, Docker supported, it only worked with AUFS, which is one copy and write file system, which has a concept of layers. And so that literally does its best to only save the differences from the base image. So, similar to a binary diff, or similar to how a source control system like Git will only store the changes, it will do its best to do that. There's also a couple of different backends now so that it has broader kernel compatibility, and they might work slightly differently. But I think the idea, the optimal scenario is certainly that, yes, only the changes are saved. So you shouldn't have to worry about that layering. It will do it for you in this commit step. Yes, so there are actually, the question was, is there an explicit export if you want to share the image? And there's a few different ways you can do that. I'll just quickly mention, I guess, two of them. So you can see here there's a save command, which will save an image to a tar archive. So that's a portable format. You can save it to a tar file. There's also, so that saves an image. So an image being a starting point for a container. There's also export, which streams the contents of a container. A container is like a running or having run instance of an image to a tar archive. So that's another way to export a container. And then there's also Docker push and Docker pull, which works with registries. So hopefully that answers the question. Yes, there is a way to import and export these different containers and images. So I guess, thank you.